Find the area of the region enclosed by the curves x equals y squared and x equals 4. Since both of these curves are given to us in the form x equals a function of y, we're going to be integrating with respect to y. So let's take a look at what these curves look like. We know that x equals y squared is a parabola that's opening upward from the origin. So it's going to look something like this. And we also have x equals 4. That is a vertical line that goes through 4 on the x-axis. And we have a very beautiful region in between those two. And we can see very clearly the interval that we're looking at with respect to y is going to be from -2 to 2. And yeah, this is pretty nice. So we've got the area equals the integral from -2 to 2 of the difference of those functions. And with respect to x, the larger function, or the one on the right, is x equals 4. And then we've got minus x equals y squared dy. And we're good to go. In fact, we can use a little trick here. This is an even function, and we're integrating an even function where our limits of integration are opposites. So we can say that this is actually equal to twice the integral from 0 to 2 of 4 minus y squared dy. That makes our lives a little bit easier because plugging in 0 is easier than plugging in -2. So let's go ahead and let's anti-differentiate. When we integrate 4, we get 4y, and then y squared gives us y cubed over 3, evaluated at 0 and 2. And we know that when we evaluate that at 0, both of those terms vanish, so we just need to plug in 2 here. So that gives us 4 times 2 minus 2 cubed over 3. And then I'm just going to write in -0 so that we don't forget there was something to subtract, but it's just equal to 0. And then that's going to give us 8 minus 8/3 on the inside. 8 is the same as 24/3. And when we subtract 8 from that, we get 16/3. So we've got 2 times 16/3, which is 32/3. And that is our area. So there we go.